I was discussed with you about the virtual memory. That how, what is actually virtual memory and why we need the virtual memory. Now, come to the point about the advantages about the virtual memory. First of all, page will be brought into memory only when it is needed. That means virtual memory is run through an application software. That application software name is Oracle Virtual Box or VM Workstation Player. So that is also another types of application software. So whenever we run our virtual memory, so that also create the page in our computer. Another thing is written that it needs less I/O, less memory, faster response, and more uses. Whenever we install any virtual memory at that point of time, that virtual memory have automatically connected some I/O devices, logically automatically connected some logical I/O devices. Those logical I/O devices actually help our virtual memory to run in a faster response. So that's why it needs less operation. Also, it needs less memory because virtual memory converted logically, it can increase the size of the computer memory. So that's why virtual memory also needs less memory. It is faster and it is more use and it is more uses. Why it is more uses? Because whenever you need to run your virtual memory, through the virtual memory you need to run an app, you need to run a system software. At that point of time, it does not create any partition in your computer memory. It does not create it does not create any separation in the computer memory. It does not create any overload in the computer main memory. Whenever I run the virtual box at that point of time, my main operating system is already running. It never ever stops. Is also going to run another memory which is the virtual memory. So with my computer operating system, the memory I am already running, it is not gonna stop at all. It is running. Also, whenever I run the virtual, at that point of time, it also run the same working possibility way our virtual memory. So at that point of time, we does not need to stop one operating system. But whenever we are working with the segmentation, at that point of time, before go to run any operating system, it show me the options that which operating system I want to run. Whether I want to run Windows or whether I want to run Linux or whether I want to run Ubuntu. Which operating system I want to run, first of all I click on it, then my operating system is actually run that specific operating system or my computer will run that specific operating system. That is happened in the segmentation. But whenever we are working with the virtual box, already my main operating system is running. It does not create any problem and it does not create overload and overload in our main operating system. It does not block the main operating system. Already My main operating system is running. With the help of and with the contiguous way, my another operating system is also running. Pages needed more or equal references to it. So that means whenever my virtual box is running or my virtual memory is running, at that point of time, it definitely needs the resources. And it have to option when is invalid reference always equal or greater than to abroad and not in cache memory always bring to the main memory. First option is invalid reference. Invalid reference means previous class you learn about valid and invalid option. So the process that is only run, only that process have the page table and only that process have the main memory and they have the frame number. So that is called the valid reference. But whenever the process is not running, that means it does not create any page table. As it does not create any page table, that means the process is invalid. That is called the invalid reference. Another thing, whenever I go to run virtual memory and I through the virtual memory I go to run my any types of softwares. Any types of system software means Linux or Ubuntu or Windows at that point of time, automatically it is sold through the cache memory. It does not fetches from the hard disk drive or the other drive. And whenever I work with the virtual memory, it does not need the cache memory. In our computer system, it always have the cache memory because operating system is much more faster than the main memory. To make the main memory faster, we need the cache memory. But whenever we need to work with the virtual memory at that point of time, it does not need cache memory because virtual memory automatically and logically converted the hard disk into the main memory, and automatically it is captured and it is sold all of this data and file and folder as quick as possible from hard disk drive to main memory. So that's why your virtual memory does not need to have the cache memory. So guys, in this slide, if you have any question, you can ask. Now this diagram is representing the concept of the virtual memory. First of all, this is my disk. So inside the disk, I have the processes. I have process A to H. Now you can see I create a page table is created, and this is the process table. Process table has the page number. So now inside the process table, it also have created the processes. Process A to H. Now in the page table, it only hold the frame number 4, 6 and 9. So 4, frame number 4 is represented process A. Frame number 6 is represented process C. Frame number 9 process frame number 9 is represented process F. That means in the main memory you can see several blocks. In the several blocks it provides the frame number. In the frame number you can also see that all of the blocks does not have the processes. Only the frame number 4, 6 and 9 have process A, C and F. Though I have process A to H. But now my three processes running A, C and F. So that's why from the process table, the page table pays the process number and the frame number, and it provides the valid and invalid bit. So as these three processes are only running step, so these process bit are valid and others are invalid bit because my other process is not running. Example is now I am taking your class. So for taking your class, in the dashboard of my laptop, you can see a lots of lots of application softwares are there. Among those, all of the application software, now I am only running my PowerPoint slide and Google Chrome application software. So only the two page table will be created in my computer, not other page table. So this for these two process, the page table will be created. That will be got the valid operation and other page table will be got the invalid operation. So guys, in this slide or up to this slide, if you have any question, you can ask. Now, this diagram also representing that how the page concept is working. Actually, with the different diagram, it show you different concept. First of all, this is the disk drive. In the disk, there are three processes. Process 1, process 2, process 3. Already you know each of the process have a lots of files and folders. With those recommended files and folders, the process are actually running. So process 1 have 4 sub-processes. Process 2 also have 4 sub-processes. Process 3 has also 4 sub-processes. This is the main memory and my main memory hold this process 1. Look at this arrow sign. My main memory hold the process 1. Why process 1? Because now my process 1 is running, not the other process. And inside the frame number, you can see in the main memory there are several blocks, but it holds only the sub processes not all of the processes. After hold this thing, then it create the page table. So it gives the page name and it provides the frame name for each of the page name and it gives the valid and invalid bit. As all of the process are running in the page table, so all of the bit is the valid bit. Now my processor is checking the sub process one by one whether there is any trap occur or not. If there is a trap occur, at that point of time my processor won't be able to run that sub process. If my sub process is only able to run at that point of time, it won't able to run my process 1. It can move for the next process or my processor will be waiting. Otherwise, you can see there are mode, that user mode, kernel mode, again user mode. When this mode changing is happen, whenever I click on any application software, that is called the user mode. After that, my processor face the processes from the files and folders and it check whether it have all the library properties or not. That is happened by the kernel mode because kernel mode is linked up with the library properties. From your first chapter, you learned about that kernel mode is related with the properties. So kernel mode is a make to deletion, whether it has the sequence or not. After that, if there is any problem occur, it go to the user mode and give the notice. Whether if there is no problem occur, also it go to the user mode and it execute the process. That is actually happen when we run our system or when we run any application software through our operating system. So guys, in this slide, if you have any question, you can ask.